All right, and so now we are ready for our fourth special limits. And here I call that my example number 4. But with this example, let's say I am going to guide the way for half part of that, and the other half responsibility, I am going to leave that for any viewer who's viewing this lecture. Okay, so this time, example 4 is one completely standalone example on its own right here. So let's evaluate together. How about this special function? And please, anybody enroll into a calculus course as the one you're taking right now, you must have been through with all the pre-calculus courses, including the algebra and all the trigonometry. So sine of x is a function that no one viewing this video should be unfamiliar with. So the function I would like to consider here is sine of x over x. Okay, and this function has its own specialty right here. So I purposely want to let x get close to 0. So this is one special limit problem on its own. I want you, before I make any further attempt into the solution, I want anyone to, you can also pause the video if you need to, but have a good close look at the problem itself. The structure of the function is sine of x and divided by x. And then in the denominators, you can see that critically we cannot substitute this the limit point value into the function, simply just that. Because substituting in, what do we get? If we're substituting in, we got sine of 0, which is 0, over 0. Can we even divide by 0? So this work is not proceeded at all. It cannot be proceeded at all. And so, and besides, taking limits is not the same as substituting in value. So I want to find the limits as x getting close to 0. In my teaching experience, I have this as advice for anyone viewing this video of mine, but graphical approach is not explaining too well in this case right here, because in my experience out there, I haven't seen any good graphing device that can tell the truthful story of this function. So trust me on this, that let's stay with the numerical approach. So like I said, if the graphical explanation is not working out for us, you still have your other method to approach. Go with the table approach. So with the table approach, I can do it halfway, and I can leave that the other half responsibility for you to give it a try. But just as usual, we are going to approach x to 0. We're going to let x get close to 0 from the left-hand side. So here's my LHS table. I am going to suggest value. How about x here being negative 1, negative 0.1, negative 0.01, negative 0.001, and negative 0.0001. The only little advice I have now is that before you proceed into the calculation, because I want you to take your own responsibility to find out these values here. Okay, and then come up with your own prediction about from the left-hand side, what is this function approaching to as a limit if we let x coming close to 0 from the left-hand side. But now, before you're about making your attempt to calculate these outputs value, make sure you turn your calculator into radians. Keep your calculator in radians mode right here. So be sure you in radians. A lot of calculator is using this shorthand symbol, rad. Okay, keep your calculator in radians. Okay, so take your time. So now, assuming that you already took your time in filling out these values, I am not going to bother filling it out either. But let's see if you agree with my answer here. Sine of x over x. But as we were letting x coming close to 0, this whole table was all about getting close to 0 from the left-hand side. It's LHS. Wasn't your answer, wasn't your prediction 1? Okay, so if you didn't get 1 right here, double check with your calculation, but I'm sure as you have done about 5 steps here and getting pretty close to 0, but from the left-hand side, all of your outputs value should be showing getting close to 1. And like I said, I'm giving quite a live lecture here, so I want some part of the work here the viewer is going to have some completion of these work on your own so that you can learn along the same way. But now, once everybody is agreeing with my answer from the left-hand side as we were letting x get close to 0, let's consider the other way around. So just like that, I really want to build that strong foundation for anyone that before we learn the good stuff later, that anytime you're finding a limit, you strictly have to understand that we're getting close to that limit point from the left-hand side. Make some estimation, and then we're getting closer to that limit point from the right-hand side. And that's what I'm about to do for this current problem. So right-hand side, how about I am going to generate a table x being 1, positive 1, because it's from the right-hand side of the limit point, and then 0.1, and then 0.01, and then 0.001, and last one is, which is good enough, 0.001. And once again, just like that, I want the part where filling out these, the part where these output values are being filled out, I want viewers to my lecture here to complete this table on your own and take notes on your own if you're learning this material, this course with me right there. All right, but so after you have filled out your own output values here, see if you agree with me that observation on your own output values is telling you that this function sine of x over x, as x is getting close to 0, but from the right-hand side this time, from the right-hand side. And remember, it would be very sad if you keep watching me but without doing your own work on this. So you need to have this before you can understand what I'm moving on here, how I'm getting this here. Otherwise, if you're leaving that all blank, and please don't blame me that I did not explain, because you can find some explanation on your own. But this answer is also 1. So approaching x values from the right-hand side, approaching 0 on the x-axis from the right-hand side, your calculation should give you this estimate that this limit from the right-hand side of 0 is also giving our function coming to that limit equals 1. So what is the overall final limit here? All right, and so really let me erase out all this here so that I can keep our special limit here very nicely written out and clear here. But this overall limit, as you already have learned, equals 1, generally from both sides. All right, and so put this into your list of special limits for the, and then keep that as a handy pocket reference for the rest of the your time studying calculus right there. But and for my face-to-face classes, I normally refer to this as special limit number 4. Yeah. Okay. And then before I'm moving out of that special limits number 4, let me again emphasize, we've done, this is our 3rd lecture on the concept of limits, and the 3rd lecture on my calculus series altogether. So you can see that, again, I keep emphasizing that, see, for example, a function like this. With the given value x equals 0, we cannot plug it in, but we were able to find a limit. So there was limit existing. There was a limit existing. It's not like a DNE. It was a finite limit, but plugging in was no luck. And so keep clear in your mind, once again, keep it clear in your mind, and it's your responsibility now that doing a limit problem will never be the same with doing a substituting in value problem. It's never the same as plugging in. And then later on, there will be a time we study about what are those functions where plugging in would be the same value with taking limits, and that will come shortly. Okay, but now let's make our way into example 5 right here. And yes, another special limit. So the special limit on your own, the plan is similar to example 4 right here. I am going to do halfway with my explanation guiding the way, and then the other half I'm going to leave it, most of the calculation I'm going to leave it for anyone viewing this video. All right, so How about here we're looking at cosine of x minus 1 over x. And again, I want to I want to get close to that on the x-axis. I want to get close to that limit point x equals 0 on the x-axis. Now, be aware that some textbooks out there, this is not the only way how this special limit problem is being written. Some textbook out there is writing this problem as a 1 minus cosine of x over x. We can have quite a good flexibility here, but it would give the same answer. Okay, so these two are essentially pretty much the same kind of problem right here, but it just, I see more textbooks writing it, more author, including me, I like writing it this way. All right, but once again, another problem where I advise anyone viewing this video, graphical explanation of the limits here is not a good choice. It's not very good of a choice here, simply because there are not too many graphing devices, including your standard TI calculators. They're not doing a good job in terms of telling the true story of the graph of this function, cosine of x minus 1 all over x. So don't rely too much on technology here. Let's stay with our table approach. So once again, I'm going to guide away halfway. Left-hand side, table, x here. And now let's say coming close to 0. How about a good starting point in negative 1, then negative 0.1, getting closer to 0 from the left-hand side. Then negative 0.01, then negative 0.001. Then how about one more, negative 0.0001. Okay. And so the output value here on this function, I want anyone viewing this video to try it out and have your own output values for this. And I will never show it on my own right here, so make sure you have your own. All right, but then at this point, the left-hand side limits for this function, cosine of x minus 1 over x, if we're taking limits, letting x coming close to 0 from the left-hand side this time, please get these output value calculator on your own, because we can't, you won't be able to understand how I got this. But as long as, you won't be able to understand what I'm about to write here without having these output values coming out. But once you have your output values coming out right here, your prediction should come to agree with mine right here, that this is going to limit 0. But from the left-hand side, when x is getting close to 0 from the left-hand side, this one right here, after observing your own calculation value, it should come out to 0. All right, and so let's pick up pace here. So quickly, I'm going to move over to the right-hand side table. So for right-hand side, x value is on one column, the function f of x is on the other column. And so how about right-hand side? Could be a good choice to be, let's say, 1. Then we're looking down to 0.1, and then we're looking down to 0.01, and then 0.001, and then 0.0001. Okay? And then once again, another little bit of responsibility for anyone viewing this video. I want you to go ahead and fill out all the output values here corresponding to these given inputs that I have had here on the board already. Okay, and after you've made your own tries in terms of getting the outputs here, and of course keep your calculator, I should have mentioned again from the beginning of this problem, but keep your calculators in radians. Okay, so in case you haven't done that, feel free to pause the video and rewind to those earlier points and get things done properly, and you should be able to agree with what I'm about to write up here on the board. All right, so this function, cosine of x minus 1 over x, if we are taking the limits of this function by allowing x getting close to 0, but from the right-hand side this time, so limit point here for this function, the limit point is 0, but getting close to the 0 on the x-axis from the right-hand side, then hopefully you already had your calculation values here, because I'll never show those. I've done these so many years already. So I want viewers to experience this on your own right here. But your observation should come out to agree to be 0 here when you're letting x coming close to 0 from the right hand side. This limit also come to 0. So we have another special limit. Give me a moment to erase the board here. And so our limit here is concluded to be 0. This function cosine of x minus 1 over x and has limit equals 0 when we let x coming close to 0, generally from both sides. And then so just for you to know, but with for any of my face-to-face class, then I refer to this as special limit number 5. So now feel free to put it into your own the helpful or pocket reference list right there. All right, and allow me now to get to our next one in terms of the special limits right here. And we will keep having more special limits later on throughout the quarter, but at least for this lecture, I'm calling it, this is about the last special limit that we good enough for us to carry on for pretty far into the quarter here of calculus. But let me now call that example 6. And let's evaluate this special function. Now, so once again, I remind anyone, being at a calculus course, now you are supposed to see standard polynomial function, constant function, linear function, right? And what else? Trig functions, and another reminder, exponential function. So there's a little bit of taste right here, but how about e to the x minus 1 over x? And let's evaluate this limit problem as x getting close to 0 right here. So we haven't had throughout the lectures I've had so far, we haven't had any formal example considering the e to the x limits, but it's okay. We can save that for because I want to save all that the formal investigation of exponential function as one separate lecture. So that day will come. But for now, we can completely rely on the table approach again. This function is this particular function e to the x minus 1 over x is another function where graphical explanation is not telling the true story. So, like I said, I haven't seen any graphing device out there that gives the true graph of this thing. So giving the table approach is the best way for now. So once again, I am going to design the left-hand side table. So x is coming to that limit 0.0, and this is famous on its own because, like I said again, x is going to 0, and 0 cannot be plugged into this function setting, because if you're plugging that into the function, you got e to the 0 minus 1, which is already a 0, and divided by a 0, which is very dangerous when you're plugging that limit point into the function. So please stay away from that. And besides, taking limit is never the same as that work where you're substituting values in. And so here again, we are getting close to 0 from the left-hand side. So here's my LHS table, left-hand side table. I can start out with -1, then -0.1, then -0.01, then -0.001, then -0.0001. And then again, similar plan to the earlier examples, I am going to leave the output values here for viewers to complete on your own right here. So I need viewers to go ahead and obtain these output values corresponding to these inputs given here on the table. And then once you've had all that, then I will tell you what the observation should look like. Okay? So assuming you already paused the video and now resumed and had your own output value filled out here, then I hope your observation agrees with my prediction here. But I'm predicting that this function e to the x minus 1 over x and we consider we're finding the limits of this function as letting x getting close to 0, but from the left-hand side, this limit will turn out to be equals 1. Okay, and so once again, if you never filled out, if you refuse to fill out these work independently on your own, it will be very hard for you to understand this. So save yourself some effort of asking me, but before you ask me any of the question about how I got this, go ahead, make your own table of values here first. Make your own output values first, and then you will understand that the observation will lead you into making this conclusion. All right, and now let's turn our focus into the right-hand side table. So right-hand side, x values, I am going to choose 1 is to be a value from the right-hand side of that limit point, 0 0.1, 0 0.00, I mean, a little too rush, 0 0.01, and then 0 0.001, and the last one, 0 0.0001. Okay. Meant this is a 0, but my writing is a little hard to read at the bottom of the board there. And once again, I need viewers to help me out getting these output values for your function, because I won't be able to do it all here. I want viewers to experience on your own, so I'm not going to bother filling in these values. But and here it's just a standard calculation, so you don't need radians or anything like that. And so after you've had your filled out output values here on the table, I hope now your prediction should agree with mine. But for this function e to the x minus 1 over x, and that's as you're letting x come close to 0 from the right-hand side, this limit also comes to, the prediction here is telling us that this limit is coming out to 1. Okay, so left-hand side limit we have seen earlier, and now right-hand side limit, they both came to 1 as we were letting x getting close to 0 from both sides. So final conclusion can be made here ultimately for this general two-sided limits. We are now concluding that this function here, as we letting x getting close to 0 from both sides, the answer here is 1, and that is our last special limits for at least this lecture right here. And for any of my face-to-face class, then I refer this limits to my face-to-face class students, special limits number 6 right there. But really, I mean, numbering these special limits, it's just my own sense about they come in terms of the level of challenging. But really, once you understand these things, knowing them is knowing them. It's not really important about special limit number 1, special limit number 2, or whatsoever. It's more about you understand what's going on with these limits, and these are the limits that there's no special algebra working that. We just stay with the standard numerical approach, and we can get the limits done. And then once we've done, and remember that for the rest of your algebra, I mean the rest of your calculus learning course right here, then it will get a lot of your work done effectively later on.